When dealing with subpanels and remote structures like sheds, maintaining proper grounding and neutral isolation is crucial for electrical safety. Since the neutral is isolated from the equipment ground in the pool subpanel, it must also be isolated at the shed. This isolation prevents potential differences between the two isolated grounding systems, which could lead to dangerous conditions. For the feeder wire, 10 American wire gauge wire is acceptable for use as your feeder wire if it is protected by a 20 amp circuit breaker. However, if you plan to install a 15 amp circuit breaker in the shed, you should use 12 American wire gauge wire. Remember to always consult local electrical codes for specific requirements in your area. Here are the steps to wire the shed properly. Firstly, install a grounding rod. Drive a ground rod at the shed location following local electrical codes. The depth and placement of the ground rod are typically specified in the code. Secondly, connect the ground rod to the equipment grounding bar. Install a copper wire with a minimum size of 8 American wire gauge between the ground rod and the equipment grounding bar in the shed's electrical panel. This connection provides a path for fault current to ground, enhancing safety. Thirdly, isolate the neutral. In the shed's panel, connect the neutral and equipment grounding bars together using a suitable jumper, typically 10 American wire gauge wire. This ensures that the neutral and ground are bonded only at the service entrance or the source of the separately derived system. Fourthly, install circuit breakers. Install the 15 amps or 20 amp circuit breakers in the panel depending on your anticipated load and the feeder wire size. Fifthly, run the feeder wire. Run the 10 American wire gauge or 12 American wire gauge feeder wire from the pool subpanel to the shed's panel. Ensure the wire is properly protected and secured along its route. Sixthly, connect the feeder wire. Connect the feeder wire to the appropriate terminals in the pool subpanel and shed's panel. Double check all connections to ensure they are tight and secure. Now let's delve deeper into the technical aspects of grounding and neutral isolation. The purpose of grounding is to provide a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault quickly. This minimizes the risk of electrical shock and fire. The equipment grounding conductor, typically a bare or green insulated wire, connects the non-current carrying metal parts of electrical equipment to the grounding electrode system. This includes metal enclosures, conduit, and junction boxes. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, bonded together to form a comprehensive grounding network. The neutral conductor, on the other hand, is the current carrying conductor that returns current to the source under normal operating conditions. In a properly wired system, the neutral conductor should be isolated from the equipment grounding system, except at the service entrance or the source of a separately derived system. This prevents neutral current from flowing through the equipment grounding conductors, which can cause nuisance tripping of ground fault circuit interrupters and increase the risk of electrical shock. In the case of a subpanel, the neutral conductor must be isolated from the equipment grounding system. This means that the neutral bar in the subpanel should not be bonded to the metal enclosure or the equipment grounding bar. Instead, a separate equipment grounding conductor must be run from the main panel to the subpanel to provide a dedicated ground path. The size of the equipment grounding conductor must be appropriate for the size of the circuit conductors as specified in the National Electrical Code, or NEC. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers everything from the types of grounding electrodes that are permitted to the size of the grounding conductors and bonding jumpers. Some key sections of Article 250 include 250.4, which covers general requirements for grounding and bonding, 250.24, which covers grounding of service entrances, 250.30, which covers grounding of separately derived systems, and 250.118, which lists acceptable types of equipment grounding conductors. When installing a subpanel, it is important to follow these NEC requirements carefully to ensure a safe and code-compliant installation. One common mistake is to bond the neutral and ground in the subpanel, which can create a parallel path for neutral current and increase the risk of electrical shock. Another mistake is to undersize the equipment grounding conductor, which can limit its ability to carry fault current and may not provide adequate protection. In addition to following the NEC requirements, it is also important to use appropriate wiring methods and materials. All wiring should be installed in accordance with the NEC using approved conduit, cable, or raceway. Wire connectors should be properly sized and installed to ensure a secure and reliable connection. Cable clamps or straps should be used to secure the wiring and prevent it from being damaged. It is also important to use the correct type of wire for the application. For example, THHN wire is commonly used for branch circuits, while UF wire is commonly used for underground feeders. The wire size must be appropriate for the ampacity of the circuit, as specified in the NEC. The NEC provides ampacity tables in Article 310. These tables list the allowable ampacities for different types of conductors based on their size, insulation type, and installation method. When sizing conductors, it is important to consider the derating factors that may apply. Derating factors are used to reduce the allowable ampacity of a conductor when it is installed in certain conditions, such as when it is installed in a raceway with other conductors or when it is exposed to high ambient temperatures. The NEC provides derating factors in Article 310.15. In addition to the NEC requirements, it is also important to follow any local electrical codes that may apply. Local codes may have additional requirements or restrictions that are not covered in the NEC. It is always a good idea to check with your local electrical inspector to make sure that your installation is code compliant. When working with electricity, safety should always be your top priority. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Here are some additional notes. Use appropriate wire connectors, such as wire nuts or butt splices, at all connections. Ensure the connectors are properly sized for the wire gauge and are securely tightened. Secure the wiring properly using cable clamps or straps. This prevents strain on the connections and protects the wiring from damage. Have the electrical work inspected by a qualified electrician to ensure it meets code requirements. A professional inspection can identify potential hazards and ensure the safety of the installation. Remember that this information is for general guidance only, and it is essential to consult with a qualified electrician and follow local electrical codes to ensure a safe and code-compliant installation.